Beneath the hazy orange clouds of Saturn's moon Titan lies a profound mystery. This world appears strangely familiar, yet it remains fundamentally alien and unknown. For decades, the surface was completely hidden from our direct view. NASA eventually found a clever way to cut through that haze. This is the remarkable story of what they actually discovered. Our first close encounter with Titan came in the year 1979. NASA sent a robotic spacecraft named Pioneer 11 to visit Saturn. Its mission was to investigate the planet's magnificent rings and many moons. Humanity has known about Titan's existence for several long centuries. It was officially discovered way back in 1655 by Christian Huygens. The moon is not particularly difficult for astronomers to spot. As the name suggests, Titan is an exceptionally large natural satellite. It is actually a bit larger than the planet Mercury itself. It is also 50% wider than our own familiar moon, yet it remains incredibly far away from our solar system's center. When Pioneer 11 first encountered Titan, scientists were very eager. They wanted to finally see what the surface actually looked like, but all the probe could see were dense orange clouds surrounding it. The view was completely and utterly impenetrable to visible light cameras. What Pioneer could do was analyze the composition of that haze. It found something very intriguing about the moon's surrounding atmosphere. Titan possesses a surprisingly thick atmosphere that is rich in nitrogen. This atmospheric composition is very similar to what we have on Earth. The majority of our own protective atmosphere is also nitrogen gas. There was another familiar chemical discovery made on Titan as well. The probe detected the presence of various hydrocarbon molecules. So what exactly are hydrocarbons in simple scientific terms? They are molecules with carbon atoms bonded to hydrogen atoms. Most people use hydrocarbons almost every single day as combustible fuel. Gasoline and propane are two common examples of these hydrocarbons. On Titan, the atmosphere is filled with methane, which is natural gas. Why is this discovery so profoundly important to NASA scientists? A practical explanation involves their role as building blocks. These carbon-based structures are known as the fundamental building blocks for life. Important molecules like DNA and protein are built on these foundations. Here is a more familiar scientific word for everyone. Carbohydrates sound pretty much the same as hydrocarbons, and they are. But carbohydrates also bring essential oxygen atoms into the molecular structure. So if we can also find oxygen present on Titan, then we have more than just basic building blocks available. We would also have the potential chemical food to fuel life. Just so you know, there is indeed some oxygen on Titan, but we will need to look a lot deeper to find it. So please stick with me through this entire scientific story. Flying a probe close by also measured the moon's gravitational pull. This measurement revealed something a bit strange about Titan's composition. Titan has a lot less surface gravity than you would logically expect. For being so much bigger than Earth's moon, the force is weaker. This means that Titan cannot be very dense internally at all. It cannot possibly be made entirely of solid silicate rock. That fascinating fact opens up some very interesting planetary possibilities. The combination of thick air and weak surface gravity is unique. A person in a wingsuit could essentially jump off a cliff. They could then fly like a bird for as long as they wanted. It also makes a flying machine the perfect exploration vehicle. NASA found a lot of very Earth-like ingredients out there. These ingredients were hiding deep in the cold outer solar system. They knew that beneath the clouds could be a monumental discovery, a discovery that would change everything we know about life. It felt so tantalizingly close, yet it remained frustratingly far away. They would have to wait for technology to properly catch up. 25 long years later, in 2004, Cassini finally arrived. This spacecraft arrived at Saturn to continue Pioneer's initial investigation. This was a major joint project between three different space agencies. NASA, the European Space Agency, and the Italian Space Agency collaborated. Cassini carried advanced radar and infrared scanners on board. These instruments could see through the dense atmosphere of Titan. Over its 13-year mission, it would fly past Titan 127 times. It used its instruments to cut through the perpetual haze below. What the spacecraft found was truly and utterly mind-blowing. Titan is the solar system's only moon with a substantial atmosphere. This is a properly thick atmosphere, 4 times denser than Earth's. That density actually creates a reverse greenhouse effect there. It blocks out what little heat comes from the distant sun, so as we move deeper down towards the frigid surface, things change. All the methane gas in the air gets colder and colder. It eventually liquefies and falls like raindrops onto a hard surface. The surface is water ice frozen as hard as granite rock. The average temperature on Titan is negative 179 degrees Celsius. The freezing point of methane is negative 182 degrees. So it perfectly supports a full hydrological cycle with methane. This cycle includes evaporation and condensation of liquid methane. The result is flowing rivers, lakes, and seas across the entire surface. This makes Titan the only other world with stable surface liquid. The people who built Cassini were exceptionally forward-thinking and smart. They knew Titan was going to reveal something truly incredible. So the European Space Agency included a secondary probe called Huygens. It was named after the astronomer who first discovered the moon. This lander was designed to parachute down to the mysterious surface. It would take photographs during its entire long descent down. In January 2005, the Huygens probe began its historic descent. Based on Cassini images, the target was a shoreline of a lake. The probe was designed to survive landing on various terrains. It could handle mountain ranges, flat plains, or even a liquid ocean. It had enough battery life to operate for 3 hours. 2.5 hours were spent slowly parachuting downwards. When Huygens finally broke through the thick clouds, this is what it saw. We begin to make out a dark valley between brighter mountains. As we get closer to the ground, details become clear. In the middle, you can see a network of drainage channels. These streams have been cut into the sides of the mountains. Some of these would be hundreds of meters wide. They would also be several kilometers in total length. These were created by runoff from infrequent methane rains. Huygens was coming down right into the middle of that dark area. As it approaches the surface, we see there is no liquid. It is actually landing in a completely dried-up ancient riverbed. When Huygens makes contact, it makes a dent 12 centimeters deep. It bounces and then slides about 30 to 40 centimeters. It wobbles a few times before finally coming to a complete rest. As the camera looks around, the most striking revelation is not alienness. It is actually how incredibly familiar the entire landscape seems. If you mentally take away the dominant orange color, it looks Earth-like. It looks like the bottom of any riverbed here on Earth. We see large rounded stones smoothed by flowing liquid long ago. They are surrounded by smaller pebbles on a sandy-looking surface. Only these are not silicate rocks like we have on Earth. They are actually chunks of water ice frozen as hard as rock. The same is true for the towering mountains in the distance. They are also made almost entirely of solid water ice. Remember, water means oxygen is present in the form of H2O, but it is still no good for life if completely frozen solid. The muddy-looking surface around the lander is a hydrocarbon material. Scientists found it to be very much like crunchy snow. It has a thin, crispy crust on the very top layer. Beneath that crust, the material has a much softer texture. As the camera looks out, you can see waves in the air. That is heat from the probe's lamp causing evaporation. At one point, We even see a small drop of methane dew. This droplet drips down right past the camera's protective lens. As the camera pans upward, we see the sun in the sky. It appears only 1/10 the size as from Earth. Even though it is midday on Titan, the light is dim. It is only as bright as twilight just after sunset on Earth. What Huygens found was pretty scientifically amazing without a doubt, but it failed to uncover the most intriguing mystery of Titan. It completely failed to find the promised liquid methane seas. It seemed to land in the perfectly correct geological place. It landed at the bottom of a clear river channel system, but it just arrived at completely the wrong time in the cycle. So where did all of that mysterious liquid actually go? One interesting finding had to do with the Moon's methane cycle. We all know about the water cycle here on Earth, right? Water evaporates from the surface and rises up into the sky. It condenses into clouds high up in the atmosphere. Eventually, so much vapor collects that it falls as rain. On Earth, rain happens frequently due to solar energy. But on the cold surface of Titan, sunlight is very weak. Liquid methane evaporates there incredibly slowly over vast periods of time. When it does evaporate, the vapor gets stored in dense clouds. These clouds can hold massive amounts of potential rain. The result would be extremely long periods of severe drought. These droughts could theoretically last for hundreds of years at a time. They would be followed by periods of torrential methane rainfall. This would cause catastrophic flash flooding all over the entire Moon. So unfortunately, we did not visit Titan during its rainy season. But that does not mean the Moon was totally dry either. As Cassini continued its long mission, it kept observing Titan. The spacecraft continued learning more about the dynamic surface over years. What it found was fascinating about liquid methane distribution. During the dry season, liquid is limited to the north polar regions. The probe learned to spot bright reflections of sunlight. These were sunlight glints shining off the tops of liquid lakes. This identified the first definite body of liquid methane on Titan. It is called Ontario Lacus, named after Lake Ontario. The two bodies have a nearly identical geographical shape. The Titan Lake is about 20% smaller than Earth's, but it still covers about 15,000 square kilometers. Even though this lake is pretty big, it is relatively shallow. The average depth is between 40 centimeters and 3 meters. It is also an eerily and profoundly still lake. Waves only reach a maximum height of about 3 millimeters. So to the naked eye, the surface would appear perfectly flat. We are not entirely sure why the waves are so tiny. Given higher air pressure and lower gravity, waves should be bigger. Lake Ontario on Earth certainly experiences some pretty big waves. Titan even has a small ocean at its frigid North Pole. This massive body is known scientifically as Kraken Mare. It covers 400,000 square kilometers in total area. That is just a bit smaller than the Black Sea on Earth. It is large enough to experience a gravitational tide from Saturn. The liquid methane rises and falls by up to 1 meter. Although Kraken Mare is still relatively shallow for its great size, it averages around 300 meters in depth across most areas. The Black Sea on Earth reaches down over 2,000 meters. But lakes and oceans are not the only active processes. Titan also has active cryovolcanoes spread across its icy surface. We know that the surface does not have any silicate rock. It only has water ice that looks and behaves like rock. So these volcanoes do not erupt with hot molten magma. They instead erupt with a strange slushy mixture of water. If Titan is so extremely cold, how can water not freeze? The slushy magma is mixed with ammonia as a natural antifreeze. You probably know ammonia as a foul-smelling cleaning product, but it was also very abundant during the solar system's formation. It is just a simple combination of nitrogen and hydrogen. These are two of the most abundant atoms in the universe. It ended up mixed into the composition of planets and moons. It then played a huge role in shaping those alien environments. Any surface ammonia on Titan would have evaporated long ago. It helped create the nitrogen-rich atmosphere we see today. Any ammonia below the surface mixed with water ice. This allowed the ice to melt into various liquid forms. So if we look at a cross-section of Titan's interior, we see a solid crust of frozen water ice. Below that is a layer of partially frozen slush. This slush occasionally erupts out through those cryovolcanoes. Below that slush layer is where we believe a thick ocean exists. This is a global subsurface ocean of liquid salty water. It sits on top of the moon's dense rocky silicate core. There is just enough residual heat and ammonia to maintain it. So we have our water and we have our hydrocarbons present. We know that combining the two gives us carbohydrates for fuel. We also know the volcanic process allows the elements to meet. They can meet either above or below the frozen icy surface. We are not saying that there are definitely aliens up there, but there is a clear opportunity for primitive bacteria to form. This would meet the bare minimum criteria to be considered alive. That is why NASA is investing hundreds of millions of dollars. They are planning an ambitious return mission called Dragonfly. This is a nuclear-powered helicopter drone designed for Titan's skies. It will fly around the landscape and collect various surface samples. These samples will be analyzed by a mobile laboratory inside. The current plan is for Dragonfly to launch in 2028. It should arrive at Titan by the distant year 2034. This will be an incredibly complex and challenging mission for NASA. But it is the only way to solve Titan's mysteries. We will finally learn what that sandy, snow-like surface is made of. If there are any potential signs of life out there on Titan, then the Dragonfly mission will be our very best shot at finding them.